So today we're going to solve logarithmic equations. And we've already done one type of this before, where we had a log on both sides of the equations. We crossed it out, and then we set each side equal to each other. So that's going to be part of what we do today, but then there's also going to be another kind where the log is only on one side of the equation and we have to solve. So up here at the top, it says to solve a logarithmic equation, we're going to use properties of logarithms. So you want to make sure and rewrite each side to a single logarithm. So one example would be like number 5 here. I have log 45x minus log 3. So we're going to use our log properties to put those together. Okay, so then if we have logs on both sides, this is when we can cross out the logs and set this thing equal to this thing. The other type is going to be if we have a log on one side of the equation, we're going to rewrite it in exponential form. So number 1, we have a log on both sides of the equations. So since I have a log on both sides and only one log, I'm going to cross those out. So I have x squared minus x equals 18 plus 2x. So since I have an x squared, I'm going to move both of these things to the left-hand side. So minus 18 minus 2x. So x squared minus 3x minus 18 equals 0. So we want to factor this left-hand side. We get x minus 6 and x plus 3 equals 0. So set each one of those equal to 0 and solve for x. So x equals 6 and x equals negative 3. Remember, we want to verify that after the log does not give me a negative. So on the left-hand side there, if I plug 6 in, I get 6 squared minus 6. Oh, you can't even see that. There we go. 6 squared minus 6 is 30, and then 18 plus 2 times 6 is 30. So that one works. Then I'm going to plug negative 3 in. So negative 3 squared minus negative 3 is 12, and 18 plus 2 times negative 3 is, oops, put in the wrong number, plus 3 is also 12. So that one's good. So there's 2 answers to that one. Okay, so you're used to seeing that where you have a log on each side, cross it out, and solve for x. So number 2, now we have a log on only one side of the equation. So if I have the log completely by itself, I'm going to put it in exponential form. So go back to what we did in the last unit where we rewrote it in exponential form. So 5 squared equals 25. That's the same type of thing we have here. So I'm going to go to the right. So 3 squared equals x minus 5. And I'm going to solve for x. So 3 squared is 9. And then we're going to add 5 over. So x equals 14. Again, let's check and make sure that that works. Okay, so if we plug 14 back into this, 14 minus 5 is 9, and so we're okay there. So you always just want to make sure that you're not going to get a negative number. Okay, number 3. So we have a single log on this left-hand side, but before I move it into exponential form, I have to get rid of this negative 9. So we're going to divide by negative 9. So log 7 x minus 7 equals 0. So put it in exponential form. 7 to the 0 power equals x minus 7. Remember, anything to the 0 power is just 1, or you can put that in your calculator. So add 7, and x equals 8. All right, number 4. So same thing. I want to get this log by itself. Now this 7 is being added, so I'm going to subtract it. So log base 12, negative 5x equals negative 1. Put it in exponential form. 12 to the negative 1 equals negative 5x. And I'm just going to divide by negative 5. So I'm going to put that in my calculator. 12 to the negative 1 divided by 5. And it's 1 over 60. So x equals 1 over 60. Now, if I take that 1 over 60 and I put it back in here and multiply it by -5, it's going to be negative. So that one's going to be no solution. Okay, number 5. So on this side here, I have 2 logs. I have to put these together before I can do anything else. So our log property, subtraction is division. So we write log 5, 45x divided by 3 equals 1. Now I'm going to simplify that before I do anything before I put in exponential form. 45 divided by 3 is 15x equals 1. Now I can put it in exponential form. So 5 to the first equals 15x and divide by 15. So x equals 1/3. Number 6, let's combine this left-hand side. So I have a 3 here in front. It's going to move up and become a power. So 3 equals log 8 plus log x cubed. Addition is multiplication. So 3 equals log 8x cubed. And it's backwards from what we're normally used to seeing. So if that confuses you, remember, just switch sides. So our base here is 10. 10 to the third equals 8x cubed. So that's 1,000 equals 8x cubed. Divide by 8 is 125. And cube root. So the cube root of 125 is 5. Okay, number 7. I have a single log on one side, so I'm going to go ahead and put it in exponential form. 5 to the 8th power equals x to the 4th. 5 to the 8th is a very large number. 6, 2, 5. So just like on number 6, we took the cube root, I'm going to take the 4th root, and I'm going to put that in my calculator. And I got x equals 25. Number 8, let's put these logs together first using multiplication. So log, x times x plus 9 equals 1. Sorry, I have an extra set of brackets there. So if you want to go ahead and multiply that out, you can. X squared plus 9x. Our base is 10. So 10 to the first equals x squared plus 9x. Subtract 10 over. So we have x plus 10 and x minus 1 equals 0. If I solve this one, I get x equals negative 10. If I solve this one, I get x equals 1. Now, since I have a log x here, if I plug in this negative 10, that one won't work, but this one will work. So just one answer on that one. And the last one, a hiker is walking through a thick jungle according to this lovely formula, y equals log base 3, x plus 1. Y is the distance and x is the time. How many yards did the hiker walk after 26 seconds? So how many yards is y? So we have y equals log base 3, 26 plus 1. So y equals log base 3, 27. So 3 to what power equals 27? That would be 3 yards.